All right, so we were just on this last example here, and I was going to multiply each of these values by 320. So basically we're taking, the way we calculate the cost of a taxi ride is we are going to take $202.50 plus $3.20 per mile. X is our miles, okay, we're per mile. So however many miles we go, so the average cost of a taxi ride would be 4.8, okay, times 320 plus 250. It's just kind of like a math equation. So if I want to see what each of these are going to change the same way, there's only a couple of them that aren't going to change. And that's when we add. But first we multiply everything, because first you're going to take the number of miles times 320. So the first thing you're going to do is multiply every value by $3.20. Multiply. So we can do that easily and quickly on our calculator. So let's see, I'm editing and I'm going to say I just want to, in the heading of this, I want to take each of those values and I'm going to multiply them by $3.20, 3.2. So I need to go second list 1 times 3.20. And that basically changes. Everything will now become, I'm multiplying across the board by $3.20, which is the cost in dollars for average cost per mile. So 4.8 miles would mean I'm gonna an average cost of $15.36. Standard deviation would be $13.44. My median cost would be $11.52. My first quartile for cost would be $5.76. So the lowest 25% of taxi rides, when just doing the miles, cost $5.76. We still haven't included the $2.50 they charge you just to get in the taxi cab. Q3 is $18.88. So $15.36 for the mean, $13.44 for the standard deviation, $11.52 for the median, $5.76 for Q1, $18.88 for Q3, and for the IQR would be $13.12. All right, so now we're going to add 250 to every value. Now these aren't, remember, these aren't the values in the data set. We're taking all the values in the data set, the cost, the miles of a taxi cab ride, and we're using those to figure out this cost, and then finding out what then happens to these summary statistics. Now we don't need that. We know that if we add a number to all values in the data set, what changes? Only, okay, if you add numbers to all numbers in a data set, the only things that didn't change was the standard deviation, IQR, and range. Adding changes all except standard deviation, IQR, and range don't change. Okay, so all we really are, these, for the second part, the IQR and the standard deviations are the only things, that's going to stay 1344 and 1312 even if I add 250 to every value in the data set. But all the other ones are going to change by adding 250. So I just need to take and add 250 to the mean. So the mean of the cost of a taxi ride will be $17. The mean of the cost of a taxi ride that's calculated using this data will be $17.86. The standard deviation will remain the same as it was when you just multiply at $13.44. The median will add to it 250. So that would be 1314.02. Q1 will also add 250 to it, as will Q3. So Q1 will be 567,826. And if I make a little mistake adding, I'm very sorry. Q3, 1888 plus 250 is 2133, 38. And then the IQR is not going to change by addition. So these are not affected. The range, if we were finding the range, would also not be affected. The IQR remains the same at $13.12. So not every value changes by adding and multiplying. Everything changes when you multiply. All of the summary statistics will change by that multiple. Everything except the measures of spread change. IQR, standard deviation, and range. Now I want to do another example because of this note down here just to show you. When you convert measurements to z-scores, all you're doing is shifting and rescaling the data. Subtracting the mean shifts the center of the distribution to 0, and dividing by the standard deviation rescales the data by making the spread or standard deviation equal to 1. Neither of these operations changes the shape of the distribution. Alright, so if I just want to show you this. If I take and say I have these test scores, we'll just make it a small set, 65, 72, 85, 95, and 100. And I have these 5 test scores. Alright, if I put these on a dot plot, okay, there's my dot plot. Alright? Okay, so here's all I'm doing. I'm just going to put these numbers in my list, 65, 72, 85, 95, 100. And I'm going to do my summary statistics. And make sure I change it back to list 1. And my summary statistics, my mean for this data is 83.4. My standard deviation for this data is 14.84. And my minimum, 65, Q1, 68.5. My median is 97.5. My Q3, well, that was wrong. The median should be 85. Q3 is 97.5, and my maximum is 100. My IQR is Q3 minus Q1, so 97.5 minus 68.5, which is 29. My range is 35. Alright, so this is my raw data that I have, and this is basically what I have when I get your test graded. What I want to do is I want to change these into z-scores. Okay, so a z-score takes all of my observed values, so now I'm going to find my z-scores. And it takes each of my observed values, and it takes x minus the mean and divides by the standard deviation. So I can actually do that in my list. Stat, edit, I can go to list 2 up in the heading. I'm going to put this formula in my heading. Now how do I do that? The x's are in list 1 minus my mean, which is 83.4, divided by my standard deviation, which is 14.84. And I need to make sure that I put this on top in parentheses. So in the heading of the second column, I'm calculating the z-score for each of these values. I'm telling my calculator to take list 1, take 65 and subtract 83.4 and divide by 14.84 and put that in list 2 in the first entry. But I don't have to calculate any of them myself, but I'm trying to demonstrate what a z-score does to this scale right here. So I'm going to draw the new z-score graph, okay, what it's doing to these scores. Okay, so I'm going to take my list 1, I better add that parenthesis, list 1, and I'm subtracting my mean, which is 83.4, ending the parenthesis, and then dividing by the standard deviation of 14.84, hit enter. It automatically fills those in. So this score of 65 is a negative negative 1.24. It means 1.24 standard deviations below the mean. 72 is a z-score of negative 0.77. 85 is a z-score of 0.107. 0.11 will make it. 95 is a z-score of 0.78. And 100 is a z-score of 1.12. So the z-scores, remember, is how far they are above the mean. Okay? So now what I've done with this set of data, I have changed. Now I'm going to take, these are my z-scores. This means that 64 is 1.24 standard deviations below the mean. If I draw in here here's the mean. Okay, here's the mean for my original data. A standard deviation is 14.84. Okay, so 83, the one standard deviation below the mean will be, take all of that data in. So can you see that that's outside of one standard deviation? This is just inside, negative 0.77. This is very close to the mean, so it's not that many standard deviations above. This between 83, 93, okay, this also falls in one standard deviation here, and this falls above one standard deviation. Okay, so I just want to show you that the mean of what the mean of z-scores is. So for list 2, I'm going to calculate one variable stats, but this time for list 2, my z-score list. And my z-score list, when I've translated all the values to z-scores, I've changed the mean to 0, the standard deviation to 1, n is still 5, my minimum is negative 1.24, Q1 is negative 1, okay. Basically, you just need to see that the z-scores, mean, and standard deviation. The mean of the z-score is 0, standard deviation is 1. Alright, that should be enough to do your homework. There is an AP question. The AP question that you're going to be doing is 2006 Form B, number 1. Okay, you have to be able to read that graph. So you should look on Canvas for that and print it out. You should read pages 102 to 107 and do the homework problems from page 130. And the next time I see you, we'll be reviewing and doing another AP question. These homework problems you'll probably get most of the time to work on in class. I would start right now reviewing chapters 2 through 6. There's a review with answers on Canvas. It's been posted since the first day of this group of sections. So in fact, if you get 16 and 17 done, that's fine, but 16 is due the next time we get together. 17 is due the day of the test.